It's Emilia from CODEstantine Meetups, and I will be your host at today's meetup. It's my pleasure to welcome you all. I would like to thank you, Jason Yee, for being a part of the 6th CODEstantine Meetup named End-to-End Incident Analysis. First of all, as you all may know, CODEstantine is the largest community in South Serbia for experienced developers. And this year, we are going global. Since we became a large community, we decided to organize a series of meetups with amazing international experts and various topics from the newest technology trends. The meetups are organized by No Limit Hub, a non-profit NGO from Serbia that supports developers, but also young entrepreneurs. And as I've already mentioned, today we have Jason Yee as a speaker. Jason is a director of advocacy at Kremlin, where he helps companies build more resilient systems by learning from how they fail. He also leads the internal chaos engineering practice to make Kremlin more reliable. Previously, Jason worked at Datadog and MongoDB. And what's also amazing, outside of work, he enjoys drinking whiskey, cooking everything in a waffle iron, and making craft chocolate. Today, Jason is going to talk about methods and techniques for gathering information and effectively using that information to avoid failure in the future. He will cover best practices for gathering system-related data, including monitoring and logging. Also, how we can use the data to formulate actionable response plans, how to validate your plan with chaos engineering, and to avoid repeating failure. Just feel free to ask as many questions as you want related to this topic, write comments and concerns, and enjoy the talk.
Thanks, Emilia. So I will go ahead and share my screen, and I think everyone can see that. So yeah, welcome. Thank you so much for joining. It's an honor to be here, especially for Serbia, which is a place that I've wanted to visit and I haven't yet. So maybe this time next year, we can all get together and hang out in Niš. So before I dive into the topic, maybe some funny tweets from my friends at Honest Status Page. Maybe this seems like something that you've encountered. Everyone knew how to fix the problem, except for then it was in Kubernetes and suddenly we didn't know how to fix it. And since we are talking about incident analysis, probably one of my favorite tweets from my friends at Honest Status Page. A post-mortem, yeah, that would require us to actually maybe have some idea of what just happened. Or maybe this is you, as you have an incident and you go into the analysis and you're like, yeah, are we actually trying to solve this, or am I just trying to prove that I know what I'm doing? So I laugh at these tweets because they are funny, but I think the reason that they're funny is they're at least a little bit true, right? They wouldn't be funny if they didn't apply, if they were just, completely crazy. But I think we've all had that experience of we have an incident that happens, and not only is it like we don't really know how to fix it, but we go to analyze what happened and we're not really quite sure, or there's something in the back of your mind that's thinking, maybe I don't know what I'm doing. Well, I want to reassure you that you do know what you're doing. I'm sure of it. You're all great engineers. Even though I haven't met most of you, you're an engineer for a reason, and that's because you're good at what you do. So we're going to talk about end-to-end incident analysis. I don't have to go through this slide too much. It's my default intro slide. Emilia already covered a lot of it. One of the things on here, though, that I do want to point out is my email address, JYEE or JYAA @gremlin.com. is my email address. So if at any point you have questions or you want to find me on LinkedIn, go ahead and use that. I'm happy to connect, and I'm always happy to answer your questions. So if you think of anything after this session is over, feel free to reach out. Don't hesitate. I'm always wanting to help people improve their skills. I do work for a company called Gremlin. Gremlin builds a chaos engineering platform. We help you proactively improve your reliability. We'll talk a little bit about chaos engineering later. There is a link here for a free ebook on how to reduce your mean time to detection for incidents. And I'll post these links later as well. They'll be up on a resource slide at the end. But to dive into the topic, what do we mean by end-to-end, right? We hear end-to-end a lot in various use cases, end-to-end testing, end-to-end everything, really. And it seems like it encompasses everything. So what does that mean for incident analysis? And I think incident analysis begins early, even before the incident actually occurs. And I think it ends very late, much later than what most people would actually consider incident analysis, because I think that we need to spend more time on not only resolving issues, but doing some testing. So when I say that incident analysis starts before the incident, I say that because we need to collect data. If you don't have data, you're not going to have much success analyzing your incidents. That makes sense, right? But we can't analyze what's happening if we don't have any data, if we don't have anything to analyze. And a lot of times people don't collect that data because they think it's too expensive. If we collect all this data, we need systems to store that data, and then that just costs too much. And the one thing that I like to remind folks is that collecting data is actually cheap compared to outages. You can store 500 terabytes of data in the cloud in an S3 storage bucket for less than 9,000 euros a year. If we look at the cost of an outage, though, 9,000 euros, that's 5 minutes of downtime for most companies. Right? Most companies, in 5 or maybe even 10 minutes of downtime, you'll lose tens of thousands of euros in value. So if you compare 1 year of storing half a petabyte of data versus the cost of the outage, storing data is cheap. So you should just do it. But then it comes to the question of what data. What data should you store? What data should you collect from your applications and your systems? So recently, someone pointed out this wonderful acronym to me, LMAO. It doesn't mean laughing my ass off, but it does mean this. In terms of data, what do you need? You need logs. So first off, the L, that logs. You need to emit useful data from your applications. So whether you're a developer and you're writing applications, I know I've been there. We all write that error message that says, a problem occurred here. And so you as the developer, sure, you know where to look. You kind of know what that means. But as other people start to run your applications, that information isn't so clear. So when you're having logs, when you're writing out those logs, number one, make them structured, right? Rather than just emitting long strings of messages, try to format that into a JSON object, something where you have the idea of a key and a value. And that helps provide some context to people to know what that information is. It also helps it easier to parse later for logging systems. So you'll reduce some of that resource overhead. But overall, think about your logs. Think about what somebody who didn't develop the application would need in order to understand this error. Right? Same for your systems. If you're operating infrastructure, think about how you're handling your logs. Where's that going? How are you going to be able to find this information later in a meaningful way? The M in LMAO stands for metrics. This is our traditional monitoring systems. Metrics are extremely valuable for providing us with a snapshot of the current state of a system, but also the history of it. And that's why we have those nice charts that go up and down, and that we can easily see, where's my system at now, or where's my application, how's it operating now, and what was it like in the past. And this helps us evaluate, is it doing okay or is something wrong? When that something goes wrong, you need alerts. You need to know in an automated way when something goes wrong, because nobody wants to stare at dashboards all day, watching these graphs go up and down. They really want to just do their work. You want to do your work, write cool code, build cool applications, and you want to be alerted when things go wrong and not have to constantly check for that. When you have those alerts, though, similar to the logs, they need to be actionable. They need to provide all of the information that somebody would need, somebody that is not you would need in order to get the job done, right? Think of the junior members of your teams. If they were to receive this message, could they actually do something useful with it? And the O stands for observability. And we hear this word a lot, especially in the SRE world. Observability this, observability that. What does it actually mean? Well, observability really is tracing or distributed tracing. And the idea here is the ability to follow a request or a piece of work as it enters your application, as it goes through each service or each function within your code, to each server, if you're in a distributed system. Where are these requests going? How long is it taking? This allows us to find where those problems are and how they bubble up, how they affect other systems. So that's the before, is capturing all of that important information. During the incident, you need that data so that you can solve the problem. This isn't really the analysis, but it generally flows like this. The alert, something goes wrong, something's abnormal, it's impacting your customers, right? And this is why you need all four of these. You need the metrics to understand how the resources that are supporting that larger business function are behaving, especially compared to the past, right? In the past, when it was working normally, what does it look like now? How are these resources that support my application actually looking like now? That gives me an idea of what could possibly be wrong. You need the observability then to be able to see the requests that come into your system. How do those requests get to the systems that are showing that anomalous behavior, that strange behavior? And once you identify those systems and you can start to hone in on what went wrong, that's where your logs are important. What error messages are those impacted systems emitting? And again, this is why you need really detailed informational log messages. Because once you've dug down and tried to find that problem, this is where you'll have that information to hopefully be able to resolve it. Now, I mentioned again, though, that troubleshooting or solving that incident, remediating it, isn't analysis. So number one tip, if you're still responding to an incident, it's not time for the analysis. I always have to say this again. If you're still responding to an incident, it's not time to do analysis. A lot of times I see engineers, they're in the middle of a problem and they start trying to work through things, right? What are the larger fixes? When you're in an incident, your goal is to get things back to a functional state. That often is rolling back your code, right? Going back to the last known good deployment. It's not moving ahead. So if it's faster for you to roll back, roll back. Don't worry about trying to fix or resolve that new feature that you just deployed, that something was wrong and took down the entire site or application. Roll back, get your customers back to a happy state, and then work on things offline or separately. But all that said, you can take notes. So as you're in the middle of an incident, you will often see strange things that you should take a look at later, but they're not directly involved in supporting your customers and getting them back to a state where they can do what they need to do. So I always highly recommend, especially for companies that are using chat tools like Slack, Microsoft Teams, etc., take notes. As you see those things, I like to just do hashtag notes or hashtag postmortem. And I tag things. So in this case, for example, this incident, I saw weird behavior in the load balancer. We should have evaluated those configs, but I knew that that wasn't part of the problem. It could have been part of preventing the incident later on, though, from recurring. So I just wrote a note. Once we start to do the incident analysis, I can easily search for these notes within my chat tool, and we can start to incorporate them. So all that said, we've gone from preparing and getting all of the data that we need. We've remediated the incident. We've gotten our customers happy, but now we need to analyze what actually happened and start to improve our systems. So after the incident, it's all about learning from that failure. So as you go into an incident analysis session, the first thing to consider is who should be a part of this, right? Who do we want involved in the process of learning or helping us learn? And the first is quite obvious. It's the responders. Everybody who participated in fixing the incident should be a part of it. That makes sense. And oftentimes, though, people stop here. You think of, I had an incident, I pulled in the developer team or the service team for that application. We had the incident commander. We had maybe some other subject matter experts or the SRE or the DevOps engineer. Cool. That's fine, but if you stop there, you're missing a lot of information. So I also recommend that you try to find the identifiers. Who actually noticed this incident? Now, you may not have this. You may have had an automated alert that fired, and so your response team went into action and you didn't have an identifier. But sometimes your alerts will be faulty or missing. You won't have an alert, and you'll have an identifier. Could be somebody from another team, a service team that noticed, hey, I made an API call to your service and I got a 500 error. Or it could be a customer that said, I tried to do this action and your website was broken. So think about your identifiers. These are people that will have noticed the problem and can help you with more information about how the problem looked or how it occurred. The other is affected users. So again, this could be your customers, or it could be internal customers or in other teams that are using your service. And the reason that I say that you should have all three of these is if you think about this like a crime scene and you're doing an investigation, who would you talk to if you were a detective trying to solve a crime? Well, you would first talk to the police, the people that responded to the crime. What did they see? What was their official report? But you would also talk to the witnesses. Who are the people that were around that saw things happen? And you would, of course, talk to the victims, the people that were directly affected. And so as you think of who to involve in this process, you have to think about all of these different categories, not just the first responders, not just the responders, the people directly in your company, the people directly responsible for that application or that service. So you have the right people in the room. You've gathered the responders, the identifiers, the affected users. What are you trying to get from them? Well, you obviously want to get what people did. What were the actions that led up to this incident? What were the actions that were a part of this incident and how you remediated it? And ultimately, then you'll use that information to define what people do next. But more than just what people did, you want to try to gather what people thought. Leading up into an incident, there's often a number of things that go wrong. And the nature of people is that as coworkers and employees and teams, we all strive to do the best work that we can. Nobody goes into work and says, today I'm going to crash the system. Well, they might if they're extremely unhappy, but generally people want to do the best work they can. They go into work and they say, today I'm going to write amazing code, or I'm going to build a really cool system. And when you do that, your mindset is, what information do I have and how do I make the best decisions with that information? And so if you focus on what people thought, you can start to gather what information was available to them. And then in order to improve, you can provide more information. What information did they lack? What information was missing? And how can we provide that? And so if you focus on gaining understanding, this will greatly help your incident analysis. Try to understand what happened and what people thought. A great way to do this is to have people write down their experiences. Oftentimes, when we have an incident, especially pre-pandemic, when everybody was in the office, it was really easy to get together in a meeting room. And now it's easy to hop on Zoom and to talk about things. But I love this quote from Richard Gwindon that says, writing is nature's way of letting you know how sloppy your thinking is. When you're forced to write things down, write down that story, it becomes a little more clear when you're making logical leaps or logical jumps, things that don't quite connect. So we've talked about who and what. When should you do your incident analysis? Well, the general guideline is as soon as possible. If you have a small incident and you have time at the end of the day, try to do it that day. Try to do it as immediately as possible. There was a researcher, a German researcher 100 years ago, who did one of the first studies of human memory. And we've named this thing after him, the Ebbinghaus forgetting curve. But what Ebbinghaus discovered was that memory drops off sharply within the first 20 minutes. So 20 minutes after an event occurs, your memory significantly drops off. And then the curve sort of flattens out. So roughly around 3 days. Basically, if you're waiting 3 days for an incident review or analysis, it's the same as waiting a month. All of that memory has been lost. So try to get things done within the first day, if you can, and definitely within 3 days. One of the other interesting things is false memories. The susceptibility to remember things inaccurately increases. So it's almost the inverse curve. It increases sharply over time. And police have found this. When they ask witnesses of crimes, what did the criminal look like? Immediately after, they're able to accurately describe that person. But as time goes on, they notice that the details become extremely wrong. People's hair color changes, their height changes. Really basic things start to become very, very inaccurate. Speaking of inaccuracies, one of the things that we need to avoid as we go into incident analysis is data skew. We often think about this on our technical systems. How do we get the correct data? And I've already talked about the data that you need to collect. But when it comes to people, when you're solving an incident, when you're trying to fix things, you're often under a lot of stress. If the incident goes on for a long time, you may be sleep deprived. You may be staying up all night trying to solve this problem. And this eventually can lead to burnout. So as you think about when to schedule your incident reviews, again, trying to get things done within the first few days is the best. But keep in mind that people who have just been through an incident are stressed. They might be low on sleep. They might be burnt out. So take a little bit of time if you need to. Let people rest, let people get some food, let them have some sleep, and then come back and do your incident review. There's a number of other ways that we can skew data. And the first thing that we want to avoid as we're doing incident analysis is blame. Blame is trying to assign the fault or the incident to a specific person. And when people think of that, their first inclination, if they think they're going to be blamed, is to shift that blame, right? To not take responsibility, to say that it was somebody else's fault or some other reason. And when they do that, it means that now we're getting false data, right? So if we avoid blame, if we focus on the learning, what did people think? What information did they have versus making bad decisions? Because we realize that people try to make the best decisions that they can. So avoid blame. Blame is the #1 way that you're going to get false data and not actually be able to solve the real problems. There's also a lot of other ways that we can have data skew in our biases. So a few that often come up when it comes to incident analysis is anchoring bias, putting too much weight on one particular fact and ignoring other facts or other collaborating causes. There's also hindsight bias, and this is one that we often fall victim to. Hindsight bias, when you're after an incident, it becomes very clear why things happened the way that they did. But moving forward in time, when you started that incident, you didn't have that information. And so don't make the mistake of retrospectively questioning the actions that people had or how things occurred, because they didn't have that information at the time. So rather than using hindsight bias to maybe start to blame people or to imagine situations or information that didn't exist at the time, use your hindsight to actually try to provide that information, to make steps moving forward. Outcome bias is another one. We often think that good decisions result in good outcomes, or bad decisions result in bad outcomes. This isn't true, especially in incidents. The outcome rarely is dictated by the quality of decisions or actions that people make. For example, as mentioned, I like to drink whiskey. In my introduction, you heard Amelia say that I like whiskey. I love traveling the world. Almost every place in the world has a distillery, and most distilleries make some sort of whiskey. We all know that drunk driving, getting drunk and driving around in a car is an awful decision. That's a really bad decision. Do not do that. But I can go driving drunk and not get into an accident. I can drive and maybe not crash, but not crashing a car while you're drunk still doesn't make that a good decision, right? So again, outcomes and decisions aren't really linked the way that we often think they are. So avoid outcome bias. And then availability bias. And this is really just talking about what's available and biasing towards that and how we do things. There's plenty of biases though, so I'm not going to go into too many of them. Those were the top ones that I've seen in my experience of incident analysis. So let's talk about a framework though. So I've given you a bunch of sort of general vague pointers or best practices. And I know that that's often like, okay, these are great tips, but how do I actually do it? So this is an incident analysis framework that we used at my time when I was at Datadog. And it's something that I've evolved a little bit over time and started to apply in my other work. And it really has 5 sections. So those 5 sections are a summary. So you want to keep everything summarized at the top. Then this is because we would share these analyses as widely as we could in the company. So not just to our team, but to all of engineering, to everybody beyond that, especially to things like customer support or customer success teams, so that they could actually have the knowledge and communicate with customers or folks having problems. The second section is how was it detected? So we'll dive into that in a bit. How do we respond? So this is kind of the core of things, starting to get that information of what were the action steps, how did it happen, which is the most important. It's trying to understand how failure actually occurs. And then ultimately, how we can improve. What are the things that we're going to do? What are the processes that will change? Or how can we make our systems better so that we don't have incidents or outages? When it comes to the summary really had a few main points. Number one, though, the most important thing to keep on your mind is what's the customer impact? We all provide some sort of service to customers. Again, whether those are external, if you're running some sort of online commerce site and you have people that are actually paying your company to do something, or if you're in a large organization and you have internal customers, other service teams or other employees within your company that rely on you. So you need to take that into account. What's the impact on those people? That will indicate what sort of severity level this incident was. If it didn't affect too many people, well, then maybe the severity was low. But we want to try to start to track what these severities are, right? We want to, over time, start to have lower severities, lower impact on our customers. We also summarized what the components that were impacted were. How broad-reaching was this incident? What were the parts of our systems that were actually affected by that? And then from a high-level summary, we wanted to gather what ultimately really resolved the outage. Right? How did we go about fixing this? It could be something as simple as, well, we rolled back the code, we deployed the last known good version, or it could be something a bit more involved. Speaking of something a bit more involved, well, this is the summary from an incident that we had when I was at Datadog. We lost one of our web front ends and our query, which was the interface from the front end to our data store. We noticed that nodes were blocked on accessing our cache, resulting in increased latency. Customers that were trying to access Datadog at that time were shown a down page and during the time of the outage, and everything seemed to be overloaded on the network side. One of the important things to note here is add pictures. You've heard that a picture is worth 1,000 words. And so adding pictures, especially those graphs, into your incident analysis is immensely valuable. We can see here from Pingdom that latency just goes through the roof. It spikes incredibly. Saying that latency spiked is very different from actually being able to see this graph. From there, we had those 4 other sections. So what are the impact on customers? What's the severity of the outage? In this case, it was a major outage. What components were affected? And then ultimately, what resolved the outage? So in our high-level summary, this got censored out because it was a little bit of sensitive information, but generally we just increased the size of those nodes. So the second section then, how was it detected? This is important. You want to get better at your detection. And again, I'll post that ebook, How to Reduce the Mean Time to Detection. I'll have that in my resources later. But we want to ensure that we're getting faster, that we're getting better at catching issues before they become major incidents, right? It's not always possible to completely not have incidents, to avoid incidents altogether. We work in fast-paced dynamic systems. They're constantly changing. We're constantly updating and deploying new code. Incidents are going to happen, but you can get better at detecting them, and that makes you faster at responding to and fixing them. So number one, we asked, did we have a metric or multiple metrics? Was there some way to track this? Was there log messages on this? Did we see it in our observability tool? From that, if we had a metric, we want to know, was there an automated alert? Was somebody notified about this? Or were we relying on our customers having a bad experience in order to let us know what happened? We want to have those alerts. So it's very clear that if we don't have metrics or we don't have alerts, those become our important action items later. And then we want to know, how long did it take to declare the outage or the incident? How long did it take for us to see that something was wrong and to actually start to respond to it and declare that something was wrong? So if I jump back into our incident here, did we have a metric? Well, at Datadog, we were all about monitoring everything, and we used Datadog to do that. So of course, we had a lot of metrics. We also had a monitor on this, and that monitor allowed us to respond quickly. So at 3 minutes after the first 500 error was seen, we declared that incident. And so it was pretty clear that we were able to use that information to respond quickly. 3 minutes is pretty fast, but you could even get faster, right? We can start to think about how we can improve some of these alerts and some of these tools that we have to be able to see things a little bit sooner or detect anomalies sooner. Again, want to say that including pictures, including images is extremely important as you're writing up your incident. As mentioned before, I could say that latency went up, but it's very clear, what that looks like in this, right? It's not just a latency spike, it's a pretty massive spike. But we can also see that in that center on the top, the latency for our elastic load balancer, we could see a few spikes leading up to that massive one. This provides a little bit more information than just simply words could tell us. So those are the first two sections. The third section, how did we respond? Well, this is where we want to start to gather some of that people information. Who was involved, again, the responders, the incident identifiers, the affected users. This also is where we want to start gathering what they did and what they thought, right? So who was the incident owner? Who was involved? Again, responders, identifiers, affected users. And then when it comes to what people did, I highly recommend that as you're doing an incident, as you're in an incident, again, it could be really easy to hop on a Zoom call, or if you're in an office, to go into a room with your colleagues and talk about things. But that makes it hard to capture information. So I highly recommend that people use their tools like Slack or like Microsoft Teams or whatever chat tool you're using, because that creates an instant timeline of everything that's going on. So for us, at Datadog, we would use Slack. We use that at Gremlin as well. And it makes it easy. We just copy the link to the first message within that, or sometimes we'll spin up a separate Slack channel and we'll just copy the link to that Slack channel. And that creates the timeline of events for us. So we don't have to go back later and try to recreate or remember what did you say? No, did I do that first, or did you say that? What was the order of events? We don't have that confusion because we just have the timeline from Slack. Then we want to ask what went well. What are the things that we did that were really useful? Things that we want to ensure that we keep doing, if it's not an official process, we want to make that part of the official process. Right? What are the things that are going well? We also want to ask, where did we get lucky? What are the things that happened that prevented this outage from cascading or from growing into a major catastrophe? What are the things that helped us out that we didn't plan for, that were just serendipitous, that just happened? Can we identify those and incorporate those into our processes? Or if it's something technical that helped us out that wasn't intentional, can we actually look at that code and improve that and make it better? And then finally, what didn't go well, right? Where did we make mistakes? What information was missing that caused us to do the wrong action or make a poor decision? right? How can we identify those things? So jumping back into our incident, we see that the incident owner was Jeff, responders, things like that. We have, again, that link to our Slack. And we also provided links to our dashboards at that time. So we were able to mark some graphs. And within Datadog's tool, there's a concept called notebooks. It allows you to take your graphs from your dashboards and embed them into a document within the application. But again, this could be anything. So Google Docs, whatever documentation tool you use, ensure though that you're copying that information, those graphics, the graphs, the images. And then we have a timeline of events. So this was generally, we took the Slack and we pulled out the high level information and created a shorter timeline. Can't stress enough though, how useful Slack is, right? Being able to see this dialogue is much different than trying to remember it and trying to recreate it later. So where you can, use your chat tools. The fourth section is why did it happen, right? And so this is that deep dive. This is where you want to get as technical as possible. And again, back to that quote of writing is nature's way of letting you know how sloppy your thinking is. Writing this out, writing out the technical pieces really helps. So get as technical as you can here. Dive really deep. If you're using open source software, try to dive into that software, right? Dig under the hood. Talk to your service teams. Dig into their code. What actually happened? What were the pieces that came together? Get super technical, but also remember that we're trying to learn here. And so you've got junior engineers, you've got less experienced engineers or developers on your teams. Get really technical, but ensure that you've got the information that they can understand, that they could read through this and they could become better engineers. And that leads to our last section of how do we prevent it, right? The number one tip here is link to your tickets. If you're using Jira, if you're using Trello, if you're using whatever ticketing system, how you track work, if you don't make tickets for your action items, they won't get done. So ensure that you're making tickets. But we like to break this up really into three sections. And the first is now. These are the immediate actions. And oftentimes now items might be done before you actually do the incident analysis, but be sure to track the things that need to happen right now. These are the most important. These are the critical actions that are going to prevent it from happening again. So oftentimes we have these as you're analyzing an incident. What are the things that are immediate threats, immediate risks? Track those and do them as soon as possible. Then we had the next section, and next was things that we could fit into the current sprint or the next sprint, right? Let's adjust our work. Let's add these tickets in and ensure they get done, but they're not critical. Our systems won't crash, in the next hour or tomorrow because we don't do these, but we want to ensure that they get done soon. So those are the next. And then we had a later section, and later was major planning. Oftentimes, as you have an incident, you might notice that there's something about your system architecture, there's something about your application design that maybe didn't account for something that caused a critical outage. And it might require some re-architecting. For example, you might be using a database in a way that it maybe wasn't intended. When I worked at MongoDB, we saw this all the time. People would choose shard keys, or the key, the information that would spread data out among a cluster. They would choose that incorrectly, and it would cause their cluster to get heavy usage on some nodes and low usage on others. And the heavy usage nodes would then, they would fall. They would go down because they were under constant stress. This is a major planning issue, though. It often requires a complete redesign and a large migration as you choose a new shard key. This isn't something that you're going to do immediately, and it's certainly not something that you're going to do in the next sprint. going to take months of time to do, but you need to do it. So having a later section where you can have major planning, where you can start to pull in other teams and talk about what's the plan going forward? How are we going to coordinate all of these different teams in order to make this change? And then as you've got these 3 sections, the one thing that you also want to do is keep follow-up notes. A lot of times we'll create a ticket, we'll do the task, and never really come back to the incident analysis. So when somebody goes to read it later and says, maybe they had an incident that is similar to the one you had, they pull up that old incident analysis and they read through it and they say, okay, I've got all of these action items, but I don't know what the end result of it was. I can maybe go into Jira and see that they got closed out, but where are the follow-up notes? What happened after that? So ensure that you're taking notes and that you're keeping things up to date as they get done. If I dive back into our incident analysis, how do we prevent it? Well, this is just the now section, but we saw that there were a bunch of tickets. So we saw that there are a couple tickets for that first item. It got checked off. There was a link to the GitHub commit that actually solved that. And then there was a second item. And again, we've got a follow-up note here. This wasn't done. And this is why those follow-up notes are important. Mira, in this case, noticed that this action item wasn't really done. It might not be related. So there's further discussion that's needed there. So that's our general framework, and I'll post the link to that framework as a template that you can use in a bit. But after the incident, we've got the incident analysis. It's still not quite done, right? We have all these tickets of things that we need to do. Now we need to test them. And so this is where chaos engineering comes in. And this is why when I was at Datadog, I started getting into chaos engineering and really embracing this practice, because it's extremely valuable for learning, but also in our incident analysis processes. So what is chaos engineering? I like to say that chaos engineering is thoughtful, planned experiments that are designed to improve our understanding of how our systems work and how they fail so that we can improve them. So my definition has evolved over time, but I think the key here is that it needs to be a planned experiment. And when it's a planned experiment, we can follow the scientific method. And if you remember from being in school, maybe in primary school, and learning about science and what is science and how does science work, the first is you start with an observation, right? If this was nature, you would ask, well, how do trees normally grow? How does it look, right? In our systems, observation happens all the time. How does it normally look? You see this as you're working with your applications. You see this as you're working with your systems on a day-to-day basis. You see how they function. So you should have some general observations about how your systems work. Coming out of an incident, you've now observed how it functioned. What did it look like during that failure? How did it actually respond? That's your observation. As you start to work on these fixes, the now and the next and the later, and you start to solve those tickets, you have a hypothesis. How do I think it will now react to failure, especially given the thing that I just did, that fix? How do I think it will react to failure now? It should be different than what it was before. So that's my hypothesis. And then I can set about experimenting and actually doing this. So when I do the experimentation, I first want to set abort conditions. Abort conditions are what are the guardrails? What is the fence or the wall that I want to stay within as I'm doing this test? If it goes beyond that, if I start affecting my customers or causing a real incident, then I want to stop. I want to abort. So I set those abort conditions, and then I can inject that failure. I can start to recreate that incident that I had to test the fix that I just deployed or the fix that I was just working on. And then I can constantly evaluate this. Is it working? Is it hitting my abort conditions? Do I need to stop? Ultimately, though, as we do this, we're going to be gathering more data and we're going to be analyzing. How did my application actually react? Did my fix work? Did our changes do the things that we expected them to? Because as we do these changes, oftentimes we'll write things like unit tests or other tests, and those work fine for the code. But our code wasn't just there. We didn't write code just to write code. We wrote this code. We wrote these fixes to solve for those incidents that we had. And so we need to test against those incidents. So we want to analyze for that. And then ultimately, it's science. So we want things to be repeatable. We want to repeat these tests and to continue to improve. And we want to share. We want to share this knowledge to help make everybody better. So not just our own engineering team, but the entire engineering organization, or even broader to our product teams and other people who need to know more about how our applications work. So just a quick review as we wrap this up. Number one, before the incident, you need to collect data. So if you're starting to think about improving your incident analysis, you really need to start thinking about how you can collect more data and better data about your systems and your applications. Number two, during the incident, don't focus on the analysis, focus on solving the problem. That oftentimes is moving backwards and not moving forward. Move backward to solve the problem, roll back, and then in your incident analysis, talk about how you're going to move forward. And then after the incident, focus on learning and avoiding that data skew. Blameless postmortems, blameless incident reviews, avoiding biases, focusing on what information people had at the time and how you can expose more information so they can make better decisions. In the incident review, follow that framework and then test everything that you do with chaos engineering. Use failure injection to recreate incidents to ensure that your fixes actually work. So with that said, thanks again. It's been an honor to be a part of this meetup series, and I do hope to join you in the future in Serbia. Just throw up these resources that I mentioned. So that incident analysis template, I've got that available as a Google Doc, so you should all have access to that. Feel free to copy that, use that in your own organizations. There is that Decreasing the Mean Time to Detection ebook that's available for free from Gremlin. If you want to know more about chaos engineering, Gremlin is a great place to do that. And one thing that I didn't mention from my introduction slide is I do have a YouTube channel where I've been posting videos about reliability engineering. So feel free to subscribe there. I try to get about one video every week, although I've been a little delinquent on that. So new videos coming soon.